Hi, in this video, we're going to talk about the core idea of confidence interval. So in the last video, we talked about how we will transform the normal distribution of x bar into z, which is the standard normal distribution, and trace it back to the original distribution because we know that in z, which is the standard normal distribution, probability for each range are already investigated by a lot of scholars already. So we're going to use that advantage of the standard normal distribution to actually get the probability of our range in our distribution, which is x bars distribution. So like to understand this, we need to understand more about scaling. So to make it so like into standard normal distribution, we scale it. So let's take an example with our distribution, which is x bar. So we subtract the mean of the variable, which is um, sample mean here, and is the mean of the sample mean. So we subtract the mean. So like it has the effect that our the mean of the distribution is now mu, but when we subtract it to the from the distribution, the whole distribution goes this way, like as mu. So like if there's 0 here, which is um, y-axis, then it moves this much. So it becomes like this. So the whole distribution moves to this. So it becomes the y-axis. So this has that effect that moves the mean to make it 0, right? Because the mean of standard normal distribution is 0. So this is the effect of moving the mean to 0, and we divide it by the standard deviation of the variable, which is standard error, like which is the standard arrow here, and to make the scale as 1. So let's say we have two people, one really tall guy and one is a small boy, and he walks like 2 feet. I don't know about feet, like, so I don't know, like, so let's just say like two number, like 4 6, so it's his footprint. And because like he's a small kid, like he walks only one step, right? So if he wants to walk with this small boy, let's say his dad and son, like he needs to slow down himself. So he divide his uh, walking rate, walking rate, like by 2. Then like the original walking rate was like 2, so it becomes 1. So when we divide it by the standard, it becomes the new standard here. So it becomes 1, right? So actually this he walks 2 for 1 step, but because we divided by the standard, it 1 step is originally 2, like for him. So this was just an example. So before the standard deviation, which is standard in the distribution, let's say it's a standard, like it was its own step, but because now we divide it by the standard deviation, like 1 step becomes 1 standard deviation, like this. So it has the effect of scaling. So yeah, this is what scaling actually means. So by scaling the variable, we make the distribution into the standard normal distribution, because we made the mean 0 and standard deviation 1. Okay, so we scale, which means that we can make a distribution into standard normal distribution, means that we can actually do the process reverse. We can make the standard normal distribution into any distribution we want, with the condition that that distribution is actually normal distribution. So we want to do that here, because we want to take the probability that we know in the standard normal distribution into the distribution that we want to investigate. So let's say we want 95% of data into some certain range, and it is already investigated in standard normal distribution that like it's actually 1.96 minus 1.96. But let's say it's just z, like one value, z alpha. And because it's symmetric, like it'll be z alpha and minus negative z alpha. And it is known, it is investigated already that this in this range, the whole data, the data of z, and 95% of them are living in this area. So we want to take it back here, and because this is the value that we got by this, right? And we can actually make this value like into this distribution. So, oh, it's not symmetric here. Like this. Oh, sorry, like this. So this value would be, because we do the exactly the do the process reverse. So we first multiplies the standard normal distribution. So it would be C alpha times the standard normal distribution, like this. And then because we subtracted the mean value, we add the mean value. And it would be the same here at this value, alpha. And yeah, so this would be exactly the same points as the ones in the standard normal distribution. So we know that also in this range, in this area, 95% of values of x bar are living. So based on this idea, we're going to get the final video for the to CI track. Thank you for watching.